because there's an internal resistance.
Yeah,
The
okay.
dielectric, but it takes a long time to discharge.
But I mean,
So-
a resistor can take the form of really just a motor.
You got it, that's exactly right, Mike. So in your case, this resistor is like your motor, right? And that motor is gonna discharge that capacitor if we put it across there. The question is, how fast do we discharge it? How much energy can we store? And does that help us or not? So the way that it discharges is really interesting. And I can't tell you why it's like this, but you guys have had exponents and everything, right? Yep. So there is this kind of amazing number that pops up in nature all the time. It's E, and I think it's 2.71. You know that.
I learned this today in math class.
You learned this today in math class. I love it. I love it. So it's the craziest thing. There are so many things in nature that follow this law of E 2.7128 or whatever the number is, raised to an exponent, and it can charge or discharge. And so a capacitor follows that discharge or charge law. What happens is when let's say we have 10 volts across here. We put a resistor and it starts, if V sub 0, the sub 0 means that's the time increment. So that's 0 is when we start this whole thing, right? And so V is a function of time. And so it's 10 volts, then we close the switch at T equals 0, and it immediately starts discharging. But the rate of the discharge is fastest at the beginning, and the rate is going to be the slope of this line, right? And so the rate gradually decreases until it's discharging very, very slowly. And the interesting thing about this is it's the initial voltage, 10 volts, times the voltage, the voltage as a function of time. This curve here is the initial voltage, 10 volts, times E, 2.7128, raised to the minus T over RC. It's kind of a complicated formula. This RC is what they call time constant, and it's sometimes written as RC is tau. It's another Greek symbol. You're going to learn a lot of Greek symbols in electrical engineering classes, you know. So this RC is called a time constant, and it's a constant because for this circuit, there's a given C and a given R, and those aren't changing, right? What's changing is the voltage. So this time constant is fixed.
Is that C the discharge value that they list with motors? Or
No,
batteries and
that
stuff?
C is a 33,000 microfarad.
Oh, okay.
Yeah.
That's
the C.
capacitance.
That's the capacitance,
Okay.
yeah. So in our case, C is 33,000 microfarads. We don't know what that R value is yet. We'll play around with that a little bit. But here's the weird thing, is if, let's say this RC time constant just happens to be 1, okay? And so if that was to be 1, what do you think R would be if RC was 1? You want to take a guess at that one? So let's say RC equals 1. If RC equals 1 and R then equals algebra 1 over C, right? So that's 1 over 0.033, and that equals 30.3 ohms. That's the, if we say RC, if we fix RC and say we want it to be 1, then that means if this is 0.033, then this is 30 ohms. And you multiply R and C together, you get 1. Kind of make sense? We're just saying, what if that was 1? So if that was 1, then RC, the time constant, when that hits 1 second, and the numbers here, you know, R is in ohms, C is in farads, V is in volts, and T is in seconds. And that means when you're at 1 second, that's going to discharge down to the initial voltage, V0, 10 volts, times E to the minus T over RC. And that T is 1 second, and that's 1. So it turns out E to the minus 1 is 37%. Who knows why? It just kind of is, right? And so when you're down in 1 second for an RC time constant of 1, you're now down at 0.368, or about 37% of the initial voltage. Now you're down to about 3.7 volts. Okay, kind of makes sense there?
Is that of the battery or of the capacitor?
That's whatever voltage you started out with across the capacitor. So in this case, there's no battery in the circuit.
Okay.
Yeah, in this case, this is real simplified. In this case, we're just saying we've got a simple capacitor that's kind of like acting a little bit like a battery, but we're gonna discharge it. And so this capacitor has 10 volts across it. We put 30 ohms across that, and then we close the switch for that 33 ohms, to connect that. And then we follow it with a meter, and we say after 1 second, it'll be down to about 3.7 volts. And then there's a table I put on the back here. You can calculate all these with a calculator, either MySQ or Tau. But, this is the opposite. This is the charging. So let's say 63% here, that's 37%. That's 1 minus 37%, right? And then the next one's 86. So at 2 time constants, it's gonna be about 14%. At 3 time constants, it'll be about 5% of the initial voltage. It keeps dropping off. Does that kind of make sense?
Okay, well,
Okay.
okay, so what does that do for us then?
Okay, well, and I'm taking you on the long path to get there, aren't I? I'll show you. Let me show you how this works first, because you'll get a kick out of this, I think. I have not tried this, but I'm just trusting my memory. So, you guys familiar with meters? Do you typically use analog or digital?
Digital.
Yeah, yeah.
Analog is,
Analog's kind of fun.
it is cool.
Yeah, I mean, digital's more accurate, and if I had a choice, I'd use digital. But analog's kind of neat because what happens is you can see it happening a little more in real time. So let's do this. I brought some resistors. Oh, how are we gonna charge this up though? Do you have a 12? Yeah, all right, here we go, okay. So, let's do this. All right, I'm gonna set this on DC volts, and I'm gonna put it on 50 volts, okay? And then we're gonna check this out. I'm gonna put, if I had a digital meter and I hooked it up backwards, it would just say minus. If I do it here, the needle goes that way, which is not as cool. Okay, see that?
Ooh.
So there's the needle. Now, the way you read this, the green is ohms. It'll actually measure resistance. So it responds to static electricity, as it turns out, too, because I scratched it here. The green is the resistance in ohms. The red is AC. We're not worried about alternating current. And the black is DC. So what I did is I put this on the 50 volt scale. Here's my pen. I put this on the 50 volt scale. So we look down here, we see which one of these is 50 volts. First says 250, next is 125, then 50. So we're gonna use that third line down, and here's 10, and here's 20. So you've actually got, like about 16 volts there, because there's no load on this, so sometimes the voltage is higher as well. Does that kind of make sense? So let's do this. Let's observe our polarity. That's which is plus and which is minus. Put that clip on the plus. I'm gonna put this on the minus. Yep, we'll try not to let them touch.
Oh.
Our pen is sparking. Now here's the
Start
important,
generating heat and melting stuff.
Fire!
here's the
which is
important
the
part.
positive or negative on that?
So, you see this?
We have other batteries.
That's the minus there, right? So that's the negative. This is really important. These are pretty dramatic when they explode.
Here, human shield.
So I'm just
Not the
gonna,
first time.
I'm just gonna touch this to
More
this.
voluntold, but
And that probably is all it took to charge that up, right? Now I'm gonna release it. Now we're not holding on to anything. Now I'm going to take this and put this on the negative terminal. There we go. And we've got our voltage. See how that's holding the voltage? And it's not even dropping, is it? That's because a good meter
That's
is
all it was
just,
to take the charge that the capacitor?
oh yeah, if we could have just touched it and that would have done all it was.
Okay, so it's that fast.
Yeah, and the reason why this is not discharging, at least not visibly, is because a good meter is designed with a really, really high resistance. So it doesn't mess up, it doesn't create a load and mess up the circuit you're trying to measure. Does that kind of make sense? So we've got that voltage on there,
High
all right?
resistance?
This has a very high input resistance.
Okay,
That way, if
so
you
it just
had a.
doesn't even wanna go into it.
Exactly, so
Okay.
no currents flowing through here, or very, very little. Now, let's try something. These are 15 ohm resistors, okay? So let's put 2 of these. If we wanted 30 ohms, what would we do with these resistors? We would put them in parallel or series?
Series.
You got it, so we're gonna put them in series here.
Parallel will just make it actually less.
It would make it,
Because they're like little mini bottlenecks.
Yeah.
Actually making it bigger if you put multiple resistors in there.
yep, and what would it be, you're good,
How'd
good.
you know all this stuff?
I mean, it's
And
in
you never
physics.
tell us this.
I did, but I mean, you didn't ask about resistance. Also, this does not help us. I mean, it does, but like, it's not all the details.
So what would happen if we put these 2 in parallel instead of series?
Yeah, it divides it evenly.
Yeah, 15 ohms would become 7.5 ohms. But as it is, we've got them in series, so it's 30 ohms, right? Now, let's see, Penelope, can you hold this on the negative one here? Yeah, don't worry, it won't.
That's next year for you.
Don't worry.
I don't know, you might
V
explode
equals
it.
I.
And I'm gonna put this, now we still got our voltage, right?
Oh, yeah.
But,
Well, something really started.
Okay, can you guys see this?
That was a good one.
oh,
Now, if we have 30 ohms, when I put this across here, that's gonna be like closing that switch, okay? And it should discharge. What should happen is in 1 second, it should go down to about 37%, or about 3.7 volts, and then it'll continue to discharge. Let's see what happens. There it goes. We are discharging that capacitor. Now, did you see how slow that went? Let's do this. Let's discharge it with only 15 ohms. But first we have to charge it back up, right? So let's take this guy. Here's our charging circuit. This is our battery. We're gonna put it here. And let's see what happened. Now we're back up to the 12 volts or whatever. Now this time, you notice how fast it went down before? This time, it should go down twice as fast. Isn't that cool? So it works. Physics, I love it. So, does that kind of make sense what's going on here?
A little bit, yeah.
Now, the same thing happens when you charge something. The formula here was our initial voltage times e to the minus q over tau. If instead of doing this, we monitor what happened when we put the battery on here, this is the charging circuit. It's kind of the same thing, except we start out 1 minus that quantity. And instead of, they call this a decaying circuit, because it's kind of decaying off gradually. And over here, it's charging, but it's the same kind of exponential curve. That kind of makes sense? So, why are we talking about this, right? Because somebody suggested using a capacitor in here, right?
Yeah, one of the other two ones.
And I think, but don't know for sure, that I think what they're thinking about is maybe perhaps for your beater bar to help you out with that one. So,
It's like, I mean, but we ran it and we just used so much current that it just sort of killed the whole system.
yeah, and that might be a different problem than what we're addressing here.
okay.
So, what we'll want to do on that is we can run the drive motor and maybe monitor the voltage and just make sure it's staying high enough, and then we can turn the other one on and we can put our meter across the drive voltage and see if it drops it down too low, because that.
Yeah, we're not gonna be able to do that today.
Yeah,
We're not all wired back
No,
up.
and that's fine, we can do that later. But what I did want to show you today, though, is just a thought that might help this thing be more destructive.
ooh.
Yeah.
Please share.
So, okay,
Explosion.
so here's what's happening. When I think, when that beater bar is rotating, remember we said about every 5 milliseconds, about 200 times a second, it's gonna hit something, right? Well, when that hits something, that creates a heavy load, mechanical load on that motor, and that when that motor faces a lot of mechanical load, it draws more current, right? And so it's asking the battery to provide a lot more current. And it's asking to provide it pretty fast. Every 200 times a second, every 5 thousandths of a second, it's saying, hey, give me more current, give me more current. Well, batteries don't do a really good job of providing power. They're good at storing energy, but they don't do a great job of providing instantaneous power. They provide it more gradually. Another way of saying is that they don't like to be discharged real rapidly. They just can't provide the current. Capacitors love it. They're not real great at storing a lot of energy, but you ask them for power and they'll give it to you really fast. And so this capacitor might be a way to provide instantaneous current to that beater bar. And so what I'm thinking is, I'm trying to think how we can test this out. What we can do is think about how much current that motor is drawing, and we can convert that then to an equivalent resistance for that motor, and then we can calculate how that's going to work.
How do you figure out, is there a way based on the specs that are provided to figure out how much current it's drawing?
Yeah, as a maximum, but probably to really find out, you'll probably want to test it. And the way you do that is just measure the current going to the, you can measure the voltage going to the ESC across the battery, and then if you can measure the current going to that, like a meter like this where you put it in series, then you can determine how much current's going in there.
Okay.
And then what you can say is, you say, okay, you guys familiar with Ohm's law? Have y'all had that? E equals IR, yeah. So what you can say is, I've got a battery, and let's call it 12 volts. This is the plus. And that battery is, we turn our switch on. That's going through the motor. But we can measure, we can just assume that motor is really a resistor, right? And so let's say you had 12 volts and you measured, if you measured 1 amp going through here, let's say you put a meter in here and you measured 1 amp going that direction, what do you think the resistance would be of that motor?
1/12 ohms.
It would be actually 12 ohms because
12, okay.
V equals I times R, and so your voltage is 12 times 1 times R, so it's, so R is going to be equal to 12 ohms, right? If you have 12 amps going through there, no, that's good. If you have 12 amps going through there, then it's 1 ohm,
Okay,
right?
yeah.
Make sense? So what we could do at some point is measure the current. Do you remember the maximum current that they said for that motor? It was
I
quite a
knew what it
few,
was
right?
for the ESC. No, the ESCs can handle a ton.
Yeah,
I'm not sure about the motors though.
okay. Well, the,
You want me to look it up?
Was that something we couldn't find? That might have been one of the values we weren't able to.
One of the many things.
we can
Yeah,
approximate
it
it
doesn't,
too.
it doesn't, listen, we'll have to.
If you give me the name of the motor, I'll look it up.
There, let me do some calculations here.
You were close.
It is,
This is why you are buying first one about those.
It talks about the VEC, which is the thing that powers the receiver.
I think they had like a maximum current or something like that, was like,
Well, it was,
we were looking at, we're like 30, 40 amps or something.
well, the ESC was like 140 or something.
Oh, yeah,
like that.
okay,
It's huge,
okay.
You know, I mean, way more than what we've got. Because the batteries are, these batteries are 50 amp.
These are 50 amp batteries.
Yeah.
Okay, so let's just assume max discharge on the battery. How's that sound? So here's what we can do. Let's just say
Six.
that we've got 50 amps.
But we got 3 motors that are gonna drive off of that 50 amp.
All right, yeah, you're right. Let's take half of
Which is
that.
part of it is, okay, so how do you divvy up that current between 3 motors?
Okay, well, let's do this. Let's just approximate, let's say we've got 24, let's say we want to have 24 amps going to that feeder bar. Just pick a number, right? So V equals I times R, so we can rewrite that equation as R equals V over I, right? It's gonna divide both sides by I. So we can say, all right, we've got 12 volts here,
Now, do we have 12 volts? If
What
we're
did
only
you-
doing
Was
half
it
of the-
max amps?
What were
What
you
was the
asking for?
question?
Yeah, what the max amps would be.
For the
It
motor,
says for the motor,
not the ESC. ESC is a lot higher.
their website is not have that.
Not
Then
helpful.
that's okay, 24 amps is probably not a bad ballpark just to start with. So, so what we said is R equals V over I, right? We just manipulated Ohm's law, V equals
Well,
IR.
it was, anyway, so if we got a 12 volt battery,
Yeah,
we got three motors, are we putting 12 volts
yeah.
to this?
So,
But only
yes,
24 amps, so we're putting full current,
Ah.
full voltage, but only half current.
you got it. What we're doing is, ideally, what we're doing is we're splitting that current. Let's say, here's our battery again.
But you can put full voltage towards everything then.
Yeah, so.
Okay. But that was one of my big questions.
If we were ignoring the ESC, and guys, that electronic speed controller, that's just a driver, and it gives you control over that, and it manipulates the signals going to that motor to act like brushes. They call it a brushless motor. What it's doing is switching in and out the different windings so that the poles of that motor are always hunting the next one, okay? I won't distract too much, but I can show you how that kind of works. But basically, that ESC is taking the power that's coming in. It's probably converting 90% of that power to the motor. So if the ESC is taking 12 volts in, and you want to drive the motor with 12 volts, probably almost all the current that's going to that ESC is also going to the motor. Does that kind of make sense? And that which is not going to the motor is getting converted to heat. And so if you hold on to the ESC, if it's a little bit warm, that's because you've got some losses in that electronic speed controller. But most of that current's gonna be going to the motor.
That's
They
why
designed that well.
that's why they got fans on them.
Yeah, exactly. They're never 100% efficient. But let's say this is your circuit, and this is your 12 volt battery. This is your plus. These are your three motors. You've effectively wired those motors in parallel, okay? And now what I'm showing is a resistor here. Each of those is really an ESC driving a motor.
Yeah.
Driving a three-phase motor. But what you're doing is you're taking the currents coming out of that battery and you're splitting it three ways. Right? So probably what happened when it stalled is you probably had enough current to drive the ESCs, to drive the two drive motors, but it was because there's internal resistance in this battery too. You don't show it in a schematic, but there's internal resistance here. If you draw too much current, then that drops that, and it causes the voltage here to go from 12 volts down to 11, down to 10, down to 9. And the more load you put on it, the lower the resistance, the more current you draw, the more that voltage drops. And if it drops below a certain level, the ESCs give up. It's probably what happened. So,
Yeah.
all that to say, let's just for fun, let's assume that we've got 24 amps going to that beater bar. That's pretty healthy. That's a lot. You should be able to do a lot with that. So we're back to this one. Now we got 24 amps going to that motor, and we manipulated this. V equals IR. We divided both sides by I. So now resistance is voltage divided by the current, right? So I can't write upside down very well. So that resistance is what? Half an ohm, right? That's not much. So that half ohm, that's what we're gonna plug into our RC equation, okay? So this is just what I'm thinking here. This may or may not work. So I'm thinking, let's call this R 0.5. And then the capacitor was 0.033, right? So let's do the calculation on that. 0.033 times 0.5, and that is 16, it's about 0.0165. Okay, let's call it 0.016. What are the units on that? Remember that? RC is a measure of time, right? It's a time constant. So at 0.016, that's 16 milliseconds, right? So here's what's happening. Here's what I'm thinking that's gonna help us. When that beater bar is spinning, I should be doing this at the board. When that beater bar is spinning, you've got your voltage, and every time it hits something, that voltage drops down, right? And then maybe the battery slowly charges it back up again, and then it drops down again, right? So what I'm thinking is gonna happen is we've got, if it's really half an ohm, if it's really drawing 24 amps, what we've got is, we've got our battery like this, and it's driving that motor. And this motor, that resistance is not always half an ohm. It's half an ohm when it's drawing maximum current.
Yeah.
But when it's spinning and it hasn't hit anything, it's not gonna draw anywhere near that much current. So that load is like putting a bunch of spikes on it, right? And when it puts that spike on it, that battery is trying to supply the voltage, or try to supply the current to it, but it's probably not doing all that well, because we're asking a lot of it. So what I'm suggesting, and I think this would be a really interesting experiment to run with and without, what I'm suggesting is we put a capacitor across that. 0.033 farads, and this is 12 volts. And then I think what's gonna happen is when that tries to draw that 24 amps, even though the battery is not gonna do a great job of supplying the current, this is gonna supply the current. It'll come from the capacitor, and it'll make up for that instantaneous current that you're asking that beater bar to do. And what's cool about it is we said if the capacitor is 0.033, and we just assume the resistance is 0.5 ohms, this is farads, then we said that means our RC is 0.016, or 16 milliseconds, right?
Mm-hmm.
Now, remember what we said when we calculated the 5,000 RPM, twice a second,
Okay,
or, twice per revolution, 80 hits per second, twice each time it rotates? That had, that was hitting about every 5 milliseconds. So now what's happening is that 5 milliseconds is about a third of the 16 milliseconds, RC time constant. So what that should mean is instead of coming all the way down and discharging a lot, it ought to come about a third of the way down this curve between 0 and 1. And so it'll only discharge maybe, I'm gonna guess maybe 80%, something like that. And then as soon as it's done hitting, while it's going up to while it's waiting to come around the next half rotation to hit, that battery will charge the capacitor up.
Okay.
And it'll take some of the ripple out of the voltage that's feeding that motor.
Okay.
That's the theory. We'll test it out here.
So that's the whole point of the capacitors to begin with.
Yeah.
And the reason why we weren't really working last year.
Right, and so I think the
Is
capacitor,
because we just kept bumping it down.
yeah. So I think why they suggest the capacitor is to make your beater bar more powerful and to smooth the voltage out that's driving that, as
Okay.
opposed to allowing the motors to drive both the beater and the driver at the same time.
Okay. So I'm not sure how to divvy up that power then, those 50 amps.
Yeah,
I know that in the programming of this ESC, it has a power that you want to put into it expressed as a percentage.
yeah,
So I almost think then that means how much of the amps do you want to apply to it? If
Right.
you say 100%, it's going to try to pull all 50.
yep. And if the other motor's trying to draw all 50, and the third one's trying to draw all 50, then you
And then
just
this
won't
one,
have the.
now these, like here's the things for this, and I'm not sure it doesn't have the same settings as what this one has. So these
Okay.
don't have the same settings. So like, here's the I don't know how to find the settings for that one, but this is the ESC programming guide for the drive motors.
Ah,
So you got brake reverse type and you got brake amount. Now, is that brake amount or is that some kind of like brake horsepower type thing, I wonder? Meaning that's the power. I thought that they explained that to me as in brake amount, that's how much you want it to brake when you're not putting power to it.
Yeah, there's a.
But that may be something else, I don't know.
Yeah,
And then reverse amount, which is just reverse, okay, punch control, which may be the other thing, how much do you wanna be
We already did.
putting to it? I don't, a drag brake, anyways, throttle deadband, voltage cutoff, which, you
Yeah.
can just do the auto,
Me and Nate.
brushless
were
type, and then,
deadbands.
so that's,
yeah.
that stuff doesn't really help us understand how much current we're putting towards it.
Yeah.
So,
Yeah, I'd have to go through, these are pretty specific.
anyway, so I have some of the stuff, I didn't send them to you, I have all these digitally, but I also have, these are all the little things, this
Yeah.
came up with the weapon motor, this is the user manual for the, I think this is for the drive ESCs here, so I mean, I've got some of this other information, but it can be pretty overwhelming.
It is, there's a lot. So I suspect that the settings on the ESCs may be such that you're drawing more power than you want to. And
Yeah.
there's another reason why I say
We did
that.
actually notice, cause I think we had this one originally set at 50%.
Yeah,
We said, oh, let's up it to 75, so
Right.
then we're
More's
just
better,
drawing
right?
more power,
Yeah.
which is killing us faster.
yeah,
So-
because two reasons why I say that, and I'm just guessing, cause we haven't measured anything, is one, I think you mentioned that you did pretty well in the competition till maybe halfway through, and then the battery
Really
just
like
died.
first minute. and
First
then
minute,
died,
okay. So one of the challenges you're probably gonna have is deciding how to budget the energy that's stored in your battery to last the whole, was it 3 minutes for the competition? So if you're only going a minute, then that probably tells you, you're
Well,
driving
I think we were
too
drawing
hot.
too much, which I think we probably hit all the auto shut-offs.
Yeah, like if we even
Yeah.
tried to activate the weapon, it just immediately
So
killed us, and
I think
then
that might have been what we did, so.
Yeah.
Anyways, the other team that, we got all this information from, they use this setup with these motors and they can make it work.
Yeah.
But the difference between us and them was this, last year.
Or could it be the settings on the motor? on the
It could
ESCs,
also be the
right?
settings.
I
So the
would-
other thing is, if I put 50% power to this, is that 50% of the amperage or 50% of the voltage?
So the power would be the voltage times the current, right? Power is, we talked about Ohm's law, we didn't talk about power, but power is voltage times the current.
Yeah.
So if the voltage stays the same, and then if you have the power, that means you have the current. So your
Okay.
current will go down
So you're
by-
thinking that when it says 50% power, that's 12 volts, half the current?
Yes, I think so. And if you go to
Perfect.
25%.
So we are getting the 26 volt, then out of the 2200 kV from the motor then? Because
Yeah.
because if we were only getting half the voltage,
Right.
and half the kV, then we're only at 2500 RPMs.
Yeah.
So that's one of those things I also wanted to try. And I guess there's a lot of stuff where, we just need to get this thing, we're gonna try to rewire this now.
Uh-huh.
And then we need to start, and we're gonna take this off so that we can actually run it without the weapon
Yeah.
spinning.
I think
And then
the
we need to start, taking these and putting them in there and figuring out what's really going on and
Yeah.
try to better understand what's going on.
I think the way these are set up, it's an electronic speed controller, so what that means is, in a older system that wasn't electronic, basically, it was you provide the voltage and the current, and the motor did what it could with that, and if you put more load on the motor, ask it to do more mechanically than it could, voltage would drop, and then it just would stall eventually. With an electronic speed controller, if they give you a rating, so many thousand RPM per volt, then that's probably without a load, mechanical load on the motor. And so if you give that 12 volts, you'll get 25,000 RPM. But then what'll happen is it'll keep that at that speed. It'll work real hard because it's changing the phase of the motor windings to maintain that speed.
Yeah.
Once you start to load that motor down mechanically, ask it to do more mechanically, then what'll happen is the ESC will ask for more and more current from the battery. And then when the battery hits a point where it can't do that anymore, then the ESC gives up and it'll stall.
So then after some time, would it then be able to do that? Because, like say after a reset or a little bit of time, then it was fine.
Yeah, but sometimes batteries will have what they call a bounce back.
Uh-huh.
And if you just charge them really fast, it'll drop that voltage.
Mm-hmm.
But sometimes when you take the load off, the battery voltage will come back up again.
And we'd be able to drive again.
You may have seen that with the drill, you know, the things, you use the drill, it died on you, you put it down, a few minutes later you pick it up,
Yeah,
ooh,
and
it
it
works for
can
a little
work
while
again.
now.
Mhm, correct.
So that's probably what happened.
I always thought that was
But what you probably wanna do then is take that 50%, maybe drop it down to 25%, play around with some numbers,
Okay.
so that it's not asking your batteries to provide as much current.
Yeah.
Now, you won't have as much power, but, if it were me, I'd probably,
Because you're still putting 12 volts to it.
the 12 volts is just the voltage, but where the power really comes is how much current.
I know, but if you're still getting 26,000 RPMs,
So what's
but you're
happening,
not getting as much force behind it, though.
you not get as much
You're not
force.
as getting much torque, effectively.
Exactly, because the torque or the force you're getting from it, depends on the power. And the power is a function of voltage times current. So if you provide more current, you'll get more power out of that, up to the point where the ESC burns out, because it's not designed for it. It'll
Well,
keep,
these ESCs will take more than what we have available.
they will. But I think what's happening is they're taking too much. So,
Taking too much of whatever's available.
yeah, and what's
So-
happening then, the battery's not keeping up. So you're asking more current out of the battery than it can provide. And so what's happening is the voltage is dropping down, and I think then the ESCs are
And
saying,
it gets to that cutoff,
"Sorry,
and it
guys."
cuts it off, and then we're dead.
Yeah, no,
And it's a real
Yeah.
big bad bummer in the middle of
it's,
competition when that
it's
happens.
kinda.
And then that's where we
kinda
pull the horn and go,
anticlimactic, isn't it?
we're done.
Yeah.
That was so depressing.
Let's flip
It
and
was.
stack 2 mini bots, and then when we power down, we can't power back up to do
Right.
it again.
Yeah, so
You
here's
know.
a thought, you know, I don't know how this competition works, I've never been involved with one, but it seems to me, you need enough drive power to get to where you're going. But you probably really want a lot of power in that beater bar, so it
Yeah,
doesn't
yeah, yeah.
damage, right? So
You
you
should
might,
hear it spin up.
oh, it's gotta be really
Oh, it
Sounds
dramatic.
is
like a
horrifying.
helicopter's
It's gotta be
taking
really
off,
cool.
baby.
It's,
I don't know.
You get a
if
little
the
gyro
video
effect
sound.
there from the thing? Is
well,
it
we
hard
don't
to
know, we've
steer?
never been able to.
We'll show you the video. Anyways, it was beautiful.
But you
It
might.
does make a very satisfying sound.
That's great, that's great. I got witnesses sometimes. What you might try to do is cut back the percentage on the drive motors. You drop back to 25%.
You know, that's where I don't know what the settings are for that and how to actually do that on the drive motor.
Oh, okay, it should
Yeah, we'll
say
plug
in
that
there
in.
somehow, I haven't used them, but if you can change the settings,
I'll have to,
to
I'll
draw
start looking,
less.
I'll start looking for that
Yeah.
specifically to see.
and if you have to choose between which you're gonna allow more current to go through, I'd probably go with the beater bar, right? Because that's where you really want to do the
Yeah, I
damage.
mean, the,
And you just need to get the
how big
drive to
is-
get it there,
Yeah.
right?
Our cage is only 12,
huge.
15 feet octagon,
Yeah,
Yeah.
so it's not real
But
big.
getting there, being able to move though,
But yeah, you gotta move,
you've
you
got to
gotta
be able
catch
to
'em.
move, and ramming speed isn't a bad thing.
Right,
But
right.
that beater bar's
And
gonna
just,
take
like,
care of it.
wiggling
that's where you
around.
really, where you're
Yeah.
getting your power out, yeah.
Yeah, they shot.
Yeah, we do need to be able to catch up to people, and they're moving all over the place too. And some of the really good robots, they can move, man. I mean, they're
Yeah.
It's
and
beautiful.
the second best team. I mean, they came in second place last year. I mean, they would go, and then all of a sudden they'd be lined up and they go, shoo! I mean, and they'd be just right on the other bot. Like, holy!
Wow.
I mean,
Wow.
they're like flying across the cage. You're like, wow, that's fast. So,
It was
there's.
very effective.
They understand
Yeah.
it a lot more. So
I guess that's
what
what
we really need to do is we need to figure out the settings and then start wiring it up and then start playing around with the settings and start looking at voltage and amps. And
So
Yeah.
my question is, do we need to do that here, or do we need to do that at Freedon?
No, I think.
Where's that?
Well,
Where's
Freedon is in
it's in Mentor, so it's an hour
it's in
away
Mentor,
from
so
here.
it's a drive,
Is
and
that
so
where you, what do
it's
you?
just that there's a cage there.
Oh.
They
So
have
this
the
is
cage
all
there.
about safety.
Oh, I see, I
constantly,
see, okay.
Because you just saw us when you came in, we were getting ready to spin up a weapon. Our controller on this bot is now having both of these do the wheels, right?
Oh, I
Which
see.
is great, except for one is supposed to do the wheels and the other is supposed to do the weapon.
Right.
While they're both driving the wheels, we have no idea why. That's new. And yes,
You switch the 3-prong black
anyways, yeah, we got some programming.
Oh, I
things
like you
with,
so much.
for remote.
We got that answered.
Training.
Anyways.
Yeah, so there's a lot of stuff. There's still a lot of stuff with all that stuff we got to learn.
The
But Cookie didn't know that, so I.
The safety issues have to do with the
No
beater
idea
bar
what the heck is
primarily,
going on.
right?
Yeah,
But-
even if we, like, here's this one that doesn't have the teeth
Right,
on it, but
right.
this thing
Still
still,
gonna do some damage.
that's still gonna do some damage just with this. So,
Could you?
and at one point, we put some polypropylene and put it on here and rounded it and everything, and apparently they were saying that, that could actually be more
Yeah, go ahead and take that
devastating.
spongy off for him so he can see
Yeah.
the
It
weapon.
could be more devastating because, the thing will break then, the
Oh.
polypropylene or something. will break.
Oh, I see, okay. Could you take, just a weird idea, could you take this and take some steel tubing and run it around here and then bolt it in there so it was a cylinder and then run it that way as a test
We can
unit?
unhook the weapon.
Well, but we
You
need,
know,
you need the
we need some
inertia.
resistance,
Yeah.
right?
Yeah, you need some, if we're gonna test a
Inertial
capacitor
resistance,
thing,
so-
you need
No, that's a
some.
good idea. We get like
flexibility.
And we
piece
do
of-
have a box we can spin up in,
Yeah,
like
It's a
we
small
do
one,
have
yeah.
that, a small
Okay.
one,
Not this one,
but we
that was
can't
too
do a lot of
thin.
movement in it as it, not
the
this
same
thing.
time.
I mean, it's bigger than this and thicker, so it's safer.
Yeah, we have a box
Yeah.
that's about
Bulletproof glass,
twice as
not-
long
Yeah,
as
it's
this.
bulletproof,
So it's
bulletproof
about-
glass. So we can't harm it too
It's
bad.
about this wide and about this long. So
We also
we can
could
fit
go
it in there, but that's
to
it.
a place that we have cement floor and space
yeah,
and spin it up, but we have to be nowhere near it. And quite frankly, I need a barrier between us
You
and
do,
the kids.
yeah.
Because that thing is serious business
is
when it's spinning
terrifying.
up.
oh yeah, it's gonna.
It is,
do
it is
The sound
terrifying.
of death.
And it did accidentally start spinning up last year outside of the cage and could have killed somebody. Like,
Yeah.
you really have to know
Well,
what
it
you
was
have
on
in
a
your
little
hands.
stand and it spun up and I went
And
like
we were-
this
Yep.
and I just held on to it like, someone turn it off.
Yeah, it was
I'm like, I'm
very,
not doing it, I'm
very
not moving.
scary. So that's why
Now,
every
that was
step of
even
the
when
way
we
when
still
I
had
was
the
testing
plastic
this
on
one
there.
tonight, it was
So
don't
we
do
didn't
that
even have
unless I'm
these
in the
on,
cage.
but
Don't.
it was scary. That was our scariest moment.
Yeah, that was
It was horrifying.
nightmare.
that'd be really bad.
It was-
Yeah.
So then, yeah, so here's here's our other capacitors that we bought. So we bought these for the 3-pound bot, which is over there, and then these.
we could just go on.
Oh, okay, okay.
So again, I just use my little rule of thumb, non-scientific, proportion to
Right.
come up with the size of these.
I think
Does
you
the
need
beater
that
bar
lifted.
spin about the same speed on the
That's
3-pound
fine.
bot?
No, it's a lot slower.
What's wrong?
The drum on the 3-pound bot,
It spins pretty good though.
it spins
Okay.
good, just not quite like this.
Okay,
But
so I might.
it's got some basic.
But its wiring is intact, and from what he just said, I can switch the controller problem. So if you
Yeah.
wanna play with that one, it's ready to roll.
Okay, no, I was just curious about that, because probably the capacitance is gonna be based on, your resistance was probably gonna be higher
Mm-hmm.
on the 3-pound bot, but if the speed's the same, then that,
it's-
time constant you'll be looking for will be about the same,
Yeah,
So you might-
it's not the same RPMs.
yeah. But the capacitors, those are pretty light too, so that might help.
Yeah.
I'm just trying to see if there's a way to,
No, you know what, that's a good idea. I could maybe see if we can get a piece of PVC
Yeah.
or something to
right.
take, just put this one on there, just fit it around here, and so we might be able to make that work.
I mean, that
that
could
would be-
still chew
I'll
up a
investigate.
hand, but
That's a
it's
good
not
idea.
going to.
Because then you're
You shouldn't chip
containing
anything off the floor.
any edges.
Right.
And
Well,
if
as
you
long
do
as it
happen to hit
doesn't
it,
have
you're-
those beasties on it.
Well, no, I mean,
we-
even this is enough right here.
Oh, I'm
too.
aware.
But
I'm just
If we had
saying.
this covered with a piece of PVC or metal piping or something, yeah, you're right.
Metal might be nice because you wouldn't, there's no way to fly off or something, you
Yeah.
could be assured that it would stay on there. What that would be good for testing is your ability to run the beater bar and the drive motors at the same time.
Yeah,
Right.
that's
What
a
it
good idea.
wouldn't do is replicate the pulses of load you get when the beater bar is shooting into your adversary's robot.
Yeah.
When we
But you
go
could do
to-
that as a separate experiment.
And we can travel to Freedon at any time.
Yeah.
It's
And
just a
bring
matter
something to
of,
hit
That
with
takes
us.
an entire
we need to
Saturday.
choose when. We wanna take all these spots pretty much on a regular basis to do that.
Yeah.
So we need to pick a time and a group and go, you know?
Yeah, you could, here's a thought, you could maybe do 2 experiments that are separated to keep it safe here. One is if you do the pipe thing, put the spacer so it's balanced, then you could run that and make sure you can run the beater bar and drive motors at the same time, get that balanced. Then maybe as a separate experiment, maybe you could turn the drive motors off so it can't go anywhere and chuck it in something where it can't move, put the beater bars back on, take a sacrificial dowel or whatever. And then what you could do is you could drive that in there while it's spinning with and without the capacitor. With and without the capacitor on this to see if that makes a difference.
Yeah.
Sure it
on
will.
stabilizing your voltage.
Yeah.
Yeah.
That's
I'm sure it
You
will.
can
so
separate those two.
essential.
I'm
Yeah.
sure if we just add this to this thing, it's gonna work a hell of a lot
I think it's
better.
gonna help you beat
And
your
if we
bar.
can figure out the settings, then I think that may be all we need to really do.
Yeah.
So,
I think,
so then the next question then would be, what do you think about the alternative battery idea, where you separate the power systems between the motor and the drive? So you have two separate systems so that you can put all the power to one thing.
I would, if you can get it to work with one battery system, that would be optimal.
Is it?
Because, yeah, cause I think you said you can get a little bit more energy storage with the one battery system. Because if you can somehow get it so it balances, then you could, I mean, what you would love to do is at the end of the 3 minutes or whenever you defeat your robot, basically have no more energy storage, right? You'd like to use it all up. And if you know how to design it so you got a certain amount of battery storage for the drive and a certain amount for the beater bar, then you could work it that way. But it's kind of nice to have that energy storage so whatever needs it can use it,
Correct.
right? And so that's why it's kind of nice to do it as one, I think, as long as you can make it so they both work.
Well, okay, so, I mean, just, this has got 50 amps.
Yeah,
The other ones, if you separate them, they each have 30.
right.
So if you're thinking of using half, then I can apply actually more current for the same voltage, with the
Right.
same voltage,
Right.
using a separate battery pack, and I don't have to worry about sharing.
Yeah.
I can just use it all.
How variable
So-
are your engagements? Like, do you know that an engagement is gonna use half the power for getting there and half for destroying it? See, that's the thing, that's why it's maybe nice if you can keep the energy storage together. Let's say you've got one engagement where you're chasing this guy over the place, but once you catch him, the beater bar gets him, right? So now you want a lot of that energy storage
Yeah,
for
but
your drive
you're
motors.
setting it up to where it doesn't use any more of the current. You're limiting how much current it can use.
Yeah, I would look at it more as energy as opposed to current.
But you're
And-
not applying any more current or voltage to it, so if you're not getting more power out of it.
Yeah, but it's more, so you guys, so energy is just joules, right? And
Yeah.
then power is joules per second, or watts,
Okay.
right? So I think the way to look at the whole thing is how to maximize the energy that you've got stored in that battery. And how to use as much of that energy stored in the battery to defeat your opponent. And there's like two ways of using that energy, that you have to use both of them. Some of the energy you have to use for chasing him, getting to where he
Yep.
needs to be, and the other part of the energy you have to use for grinding him
Right.
down, right?
Yeah.
And so if the engagements are gonna be different, sometimes you're gonna use more energy getting to where he is. Let's say you might use 80% of your energy getting to where he is, and then you can defeat him. Other times, maybe you're using 30% of the energy to get there,
And
but
then
you'd
you
like to
wanna-
use the 70% to
The
grind him
flip,
down.
because he's a heavier bot. or
Yeah.
there's
Well,
no
how,
so
so
if
is that,
you've
how do we,
So,
I don't
so,
understand
so
how
the,
we change that.
well, so the issue is if you stored 50% of your energy in the batteries for the drive motors and 50% in the energy storage for the beater bar, you might wish you had that energy for driving or for beating.
And
talk
I'd
about
say
the
in
overall
that case,
capacity?
you want 25% drive, 75%
I agree,
weapon.
I agree.
That's my total
Yeah.
concept of that. But ultimately, in our case, we just have to find some kind of consistent balance, because it's utterly sad to build
Oh,
all
yeah.
that and to get in there and watch
Right.
a great match. I mean, Ethan here literally flipped and stacked 2 mini bots, and they're allowed to flip back over. And in the time we power down, they flip them back over. We try to power back up. We have no bot.
Yeah.
so that is
That was-
not okay, and I can't take that anymore.
What,
Or why are we bothering to build, you know, so
what you
that's,
have is an energy management problem.
Yeah,
Correct.
exactly, and that's
So
what
hope-
we're trying to understand,
Yeah.
that's what we're
let's
trying to learn.
manage some
Let's
energy,
manage
baby,
the energy.
'cause-
Yeah,
I
know.
think the key is gonna be making sure that you are not sucking more current out of those batteries
right.
early in the competition than you want to. So you're gonna have to,
And that's all by controlling a
Probably
setting
the-
on a motor.
it's probably the percentage ratings on those motors, yeah, on the ESCs. I'm not familiar
So
with those
we have to
ESCs.
learn how to do that,
Yeah.
do you know
On
how to
the-
do that?
On the weapon motor, in the program that we used to program the ESC, it asked us how much power we wanted to put in there. So that was a very overt thing, easy to understand.
And I think you wanna crank that number down.
So yeah, I think, like you said, we started at 50%, and then
You're getting it.
I think we upped it to 75%. So it was
Oh,
drawing so
sugar
much
nuggets,
current
yeah.
that,
No.
that's why we,
Down,
so
Yeah.
we need to take it down to 50 or maybe below.
20.
Try a lower one and
Well, I
work
don't
your
know
way
that it
up.
had a whole lot of, I didn't know that it had a whole lot of settings in there, I don't know.
So
what
how
the
do we
increment
go
was.
back,
Like,
Mike,
I don't know if we could go to
where-
45, so I don't know what
how
the
do we
increments were.
backpedal to that?
Well, we could do that, so we could do that on that. Now, on the drive ESCs, it's not overtly obvious how to set the power for those.
Okay, so when you did it on the other one, what was the weapon
The
ESC?
weapon ESC, yeah.
Where in the process was that?
There's, on all these things, there's like a bunch of settings, and you set all the settings, and then you download it to the ESC.
Yeah, on the little box thing that you plug into them,
Yeah,
or the computer.
Well, for the drive ESCs, we got that little square box, the little
Yeah.
black box.
uh-huh,
Okay, but for the weapon motor, it's actually a program on a computer.
okay,
And
so,
so you set the settings, you say download, just like what they do with that robot there.
alright. So
And then
then
just
my
downloads
next
it.
question is this, once we've done that programming, right, and we wanna test, do we just need a chunk of wood to go in and hit? Like, do we have to hit something to totally understand what we've
Well, we wanna
got?
put a
Or
voltmeter
is
on
it
there,
just
right?
spinning up and driving that's enough to know? Like, do we have to maim
Well, what you're saying is
something?
like when you hit
Yeah,
something,
you'll
it
draw more
starts
current,
drawing,
you'll draw more current that way.
it
Yeah.
draws
So
more
yes,
current when you hit stuff.
so we need
Right.
to come up with different chunks of wood
But we also can't
to go,
put a voltmeter on there while we're doing that.
but if it doesn't work in the end,
But
we're
we
gonna
can
know we
drive in
got the
3
balance
minutes
wrong.
and-
You're right,
Keep
we can
hitting
drive and we can just do
We just
that.
gotta keep hitting different chunks of wood.
Yeah.
Yeah.
I
Like,
think
in my opinion.
some good initial tests would be if you can replace it with something that's a little safer and start cranking down the settings, to see if you can see what it takes to go for 3 minutes, just driving
Right.
around, just rotating it with no load on it.
Imagine
And then you could separate that, chuck it in place so it's safe.
We
and-
probably want it to go like.
Well, and my problem is
Right.
too, even
Yeah.
without those teeth, if we hit anything, it's gonna send it right through the ceiling.
Well, that's what you say, if we could put a pipe around this,
Yeah.
so it's just a round thing.
But again, once we do start to hit, it will take more.
Yeah.
Yeah,
You
it's
know,
gonna-
so we're
yeah.
going to have to test that, and that's fine. We're just going to have to find a safe arena to do so, whether it's going to
That would
Freedon
definitely be a free.
Right.
or staying here.
Or like
And
up
I mean,
at-
if it was a
near
gorgeous
the-
sunny summer
the,
The
day,
football field.
I'd go
The field.
outside and do this
Yes,
on the
launch the
back
wood into the
patio,
sun.
What about your
away from
garage?
people and
What
chuck
about
some
your
stuff.
garage?
What?
What about your garage?
No,
Why not?
because
could
I
go
have a
to
garage door open. I'd
The
like to
football
not
field.
blow up when we hit it.
At
Going
the
up
makerspace,
field.
they
Forgot about
got
that.
Yeah,
huge rooms there with
but
nothing.
again, then now we've got Devin again. I don't
No,
want
you
to
just go up there and you
deal with
find an open, empty room and you just.
And then you run a
But
lethal
that's what he
robot.
was gonna do. His
Sure, I
initial
thought-
thought was that we were gonna take the bot down the basement and he was gonna get chunks of wood to toss at it and let it just chew them up and throw things at the ceiling because that place, who cares? You're not
Yeah,
gonna hurt
exactly, that's
anything.
what I'm saying.
That's what we need. But again, Freedon is, I think, ultimately where we're heading. I just would prefer to get all this figured out
Yeah.
before an opponent, and they're
I
at
agree.
Freedon, would
Yeah.
see where we're at.
Right.
And so, I mean, they don't want us to figure this out. So,
Because I think they saw this and heard it
and they heard it all right because the entire warehouse came a running super fast when that thing showed Denny the spin up.
That was terrifying.
It was.
It was a very satisfying.
We
sound.
were
I
not
love how
ready
you
for
keep
that.
saying that. Very satisfying. Huh?
I know it's
I
Leave it
mean, it
alone.
sounded like a, you know, like.
Right now, leave it alone.
What strange commentary will be in this
Till we
video?
need it.
I
Stop
cannot
playing
promise.
it.
Oh, there's your cage,
Yeah, that's the cage they have.
If we can do it outside, why don't we just shovel outside?
Put
Well, I bet
humans
it's a
out.
little chilly.
Sam. No.
I think the weapons turns up.
No.
That's the only video we have in the test box.
Oh, is it?
So I'm assuming that that has the weapon
You're moving around
at
right
some
now.
point.
I know.
You can scroll to the weapon.
pretty quick, isn't it?
Oh yeah.
That thing was
It
terrifying.
zooms, just not in a straight line. It goes. brrr.
It's like.
There are definitely some pros here, and if we ignore the cons,